see.
Yeah, I'm not sure. Will they show it on certain notes? On that one too, because it's just a screen share.
Yeah.
7, 10.
15.
I would guess it would, yes.
Yeah, auto grow. This.
I have to remember it.
Yeah, we got right off the ground on the black.
Okay, so it's duplicating.
Actually,
That's a problem.
Oh, you want your notes? Like try and,
He's following up.
no, you're all set. Thank you. Okay, welcome everybody. Thank you for coming in today. My name is Ian Boone, and I will be presenting the auto grow. This is for our senior projects at BTC, May 2022. Finally back in person, it feels great. Okay, so what is the auto grow? The auto grow is a project designed to make daily plant watering an afterthought. The proposed project is an easy-to-use technology for kids and adults alike. It's adaptable for multiple plants, locations, and users. The use of microcontrollers, sensors, relays, and motors, all enclosed in a homemade box with a few extra accessories. Why auto grow? Have you ever came home from work and you just want to crawl right into bed? Well, checking off your daily list can sometimes be a nuisance. And for this reason, I wanted to make the auto grow. One of my tasks and one of my mother's tasks is to water the plants at the end of the day or do the chores. And sometimes you can just kind of cross the plants off the list. Every once in a while, you're like, the plants don't really need to be watered today. Well, why worry about that? Instead, you can have auto grow worry about that. So let's skip 24. How auto grow? So the auto grow is with the Arduino Uno, a soil moisture sensor, a relay and pump setup, an adjustable light control, and LEDs. So here's a view of an EagleCAD drawing that I did of the circuit. These 5 blocks right here are the Arduino pins and headers. The soil sensor is hooked up to the first analog pin, ground, and the 3.3 volt input off the Arduino. The Arduino is powered by a 5-volt regulator coming from a 12-volt power supply and adjustable power supply on the back of the auto box. The LCD screen, similar to the last presentation, is coming from our Arduino pins 4 and 5 with the SLC and the SDA. This is powered by the 12-volt to 5-volt regulator as well, but between it, it has a potentiometer. That way you can shut the LCD on and off. So if you have it staged up in your room at night and that night light's kind of annoying you, you can just turn it off, but the plant will still be auto growing. The screen will just be off. Coming off the digital pins, we have a couple LEDs. These LEDs indicate when it's pumping and when it's not pumping. One is green, one is red. And when the red LED is blinking, that means you have to refill the water tank that's inside the box. Coming to the end of the circuit, we have another 5-volt regulator separate from the system. That way that the pump and relay are always on. Because when this potentiometer goes off, it cuts out this relay. This regulator. This regulator comes into a relay, and that relay is a normally open setup and is connected to ground. So when this is triggered, the pump is pulled down to ground and it will start to pump some water. On the end of the pump, I just have a little bit of plastic tubing going into the plant out of the front housing. How auto grow continues. So this is a little bit of my code setup. It's backwards. So this is the actual top and this is what would come after. I wanted it to be flipped, but it just did not want to do that for some reason. So here you can see I have a lot more initialized than what I was talking about before. That will be discussed a little bit later, but I can give some insight to it now. It's very adaptable. So by uncommenting these and adding a few more wires, you can add a second sensor for a second plant with a second pump. And then you can have 1, 2, or even 3 plants all next to your auto grow. And so we have 3 sensors, 3 pumps, and 6 LEDs. Those are just some integers for throughout the program, having to do some calculations. And then this is our setup. So this is initializing our LCD, beginning the communication with the LCD, setting up the pins for the relays. So my relay is on pin 11, digital pin, and my LEDs are on 8 and 7. Then I have my sensor hooked up to the analog 0. Here's a little bit more of the code. So here's our loop. This loop will happen forever. It'll keep going and going and going. It will never stop. And here I have my map and the display of the LCD screen and the first parameters that should always be presented, as well as reading from the sensor constantly. After it gets through that first loop, it starts a for loop. And this for loop has a cycle of 10 counts. So this for loop is when the water will be pumping or not pumping. If it reads a value of greater than 350 analog from the A0 pin, then the water will pump and saturate the plant until it's below 350. It'll check and do this 10 times because it should not take more than 10 times to saturate the plant enough with the 3-second delay for the water pump that we have. So if this does get past that, then we go into our second for loop, which does a 1000 count. And this blinks the red LED to tell you that the water is empty. So if this threshold is not met, if it is not lowered below that threshold within 10 counts, then it's a pretty clear indication that there's no water in the jar. And so this loop will start, and I have it set to 1000 because if I have it set to just like 10 or 20, I might not see that red light blinking and I might not know until the next time it goes through the cycle. So I have it stuck in that state for a while so I don't have the pump just pumping when there's no water. And then I have a very large delay at the end of it for if I don't happen to see this check. So that way it's not going to go through this over and over and over again until I come back to it the next day. Okay, so these were some challenges I had. Pump selection, sensor faults and testing, and my timeline. So my pump selection went through a few variations throughout the semester. I had some indecisive moments. I wanted to do one thing, change it to another, and then right back to the original thing. So this was done with the submersible pump to a parasitic pump, back to a submersible pump. So the reason I wanted to switch the parasitic pump is so that I wouldn't have any shorts in the project, because the submersible pump may be not as reliable as a pump that's not inside of the water. So a parasitic pump has a reverse and forward direction where it sucks in and out of the jar and into the plant rather than just straight from the jar into the plant. But it happened to be rather difficult in code to get that to work with the Arduino. So I switched it back to the submersible pump just to get it made by my deadline. The sensor faults and testing, that's going to come up in a little bit. I have a slide, I think 2 down from here, that'll show a little bit more about that. But my soil sensor is very unreliable. There's a lot of soil sensors on the market and not many are that great. And so I was doing some research and I found common problems. I went through those common problems. One of the common problems was on the circuit board for the soil sensor, there was a soldering issue where a resistor was actually soldered to a ground pin. And so I just went in, I did a little bit of soldering on all my soil sensors that needed it and fixed those up. And then the testing was a little bit wonky because at first I didn't realize that they need to actually be in soil to measure the conductance of it. I thought you could just measure it wet and dry. And so for a while I wasn't bringing in a plant to the lab because I didn't think I needed it. And I realized I finally do need the plant, so then I could get some real testing done. Found my threshold limits for different plants and put that into code. The timeline changed a lot because like I was saying before, I had different design ideas. So I wanted to add certain things and then I removed those certain things. So what I wanted to do and how much time I allotted myself changed, and then throughout the semester, a lot of assignments, my timeline changed a little bit more. So those are my biggest challenges. Crumple those up and throw them away. So this was my timeline. This is just a continuation a little bit of how I got through those challenges. So at first, this code, R&D, and this testing were supposed to be done right around the draft build. It just so happens after the draft build, they need to be continued quite a lot further. And so the testing and the code lasted almost throughout the entire project, but it kind of makes sense because I was testing different things. I was going back and forth, trying to find something that really works for my project. Here's our soil sensor. So actually, it might be a little difficult to see, but this resistor up here, R4, it had a short between these two pins, it had a short. And so I just took some copper desolder and I desoldered that short. And then to combat any possible water getting onto that, I had a 3D house printed, and this just fits over the soil sensor. That way, when the water's pouring in, it may splash at some point, and this will protect the circuit from that. The adaptability that I was talking about before. So for my project, I just have one plant. So I have one relay, but it's very simple to have a 4-channel relay, the 2 extra sensors, 2 extra pumps, and 2 more plants. And you can have 2 to 3 plants rather than just one. And the plant types are also very easily adaptable inside the code. All you have to do, all I would have to do, is see what the level of the soil is at 0 saturation and then full saturation by overwatering. And that would set my sensor limits, and I could find a happy medium and just change that code that I had before. The delay times I could change slightly, as some plants need to be watered daily, some plants need to be watered weekly. So I could change my delay times within my code to adapt to plants that I need to water. And the indicators, the LEDs, you can use any color LEDs that you want. So if you wanted a different one than green and red, you could use a different one than green and red. It's supposed to be something in your home or your room that you like to look at and like to use. So it's really adaptable for changes throughout. Then these are a couple of the major components. This is the potentiometer that controls the soil moisture screen, the LCD screen, turning it lower and higher. This is my Arduino Uno that I used. Most of the pins are filled up because of adding the extra analog pins and digital pins for the relays. This would be a 4-channel relay if you wanted multiple plants. My project right now has just one relay mounted in it. And then this is the pump that I ended up going with, just a submergible pump that goes inside of a little water tank. Then Q&A are welcomed if they're easy questions. Thank you all for being here today and taking the time to patiently listen to what I had to say. I wish you all a great summer and good luck with all your future endeavors to my classmates.
How did you discover the short?
The short, so I discovered the short because I was getting an analog reading of 93. And no matter what I did, I was continuously getting an analog reading of 93. And so I looked online, doing some little bit of research, and I tried to find other people that use the similar sensor. And I found on a discussion board, some sort of, I forget exactly what discussion board, but some sort of electronics discussion board. And they're like, hey, this is what I did to mine. Maybe this could work for you too. So I went in, checked it out. I grabbed the digital multimeter, I put it on there, and it was a short. So then I went right to work and desoldered it up. And it only, I think I have a 5-pack and then a 3-pack because they're really not that reliable. So I got a lot of them just in case, like, because they took a long time to get here too. So I didn't want to not have them if I needed them later in the semester. So I just got a whole lot in the beginning. But only like 3 of them had the short in it and 5 didn't. It wasn't uniform. It was just bad production line. I'm not sure exactly why it was like that, but
Did the manufacturer have any say to?
the manufacturer, I'm not sure I could find them because I got this stuff off of Amazon. And when you go through, there's like 5 or 6 different manufacturers that are all giving out the same product. So I wasn't even actually 100% sure which manufacturer that one came from. They probably wouldn't have had anything to say about it.
And then you, at the very beginning, you said you had an adjustable power supply.
Adjustable power supply, yes.
Why adjust?
So I have an adjustable power supply because I wasn't sure if I was gonna use more pumps or not. And if I'm using more pumps, I'll need more amperage for the whole circuit. And the 5-volt regulators will protect my Arduino and everything else, so I can crank up the adjustable up to like 15, 18 volts if I need it. As of right now, I only need it at 10 volts to control everything that I have.
The screen, are you putting out the number and then the pin? Is that what that was?
Yeah, I was putting out the pin because if I did have the other sensors included, then I would want to see which pin was reading what. So the A0 pin would go to plant 0, A1 pin would go to plant 2, A2 would go to
So it
plant
like
3.
cycle through the.
Yeah, it would
Okay.
have a scroll feature.
Other comments or questions for you?
Interesting.
How much did I spend? Very cheap project. And I don't have my bill of materials pulled up on me right now, but it was, I think, $170 for everything, including extra parts. And so I could probably build about 3 of these and still be under budget. So actually, one of the most expensive things that I bought was the parasitic pump, which I did not end up using, which is kind of ironic, but I've seen that happen in my industry plenty of times, so it's okay.
Have you already tried it out on any plants at your home?
I have, actually, that's one of my mom's plants right there that's inside of it. And I have quite a few different plants, and my mom has quite a few different plants, so I think, like, if I can find the time, I am gonna set up the code to like water it all for her. I failed to mention this in the beginning, but anything I've ever done in school, I've just like been like, Mom, what do you need at the house? What would you like? And so it actually is coming at a decent time for Mother's Day. So this was a project for her, and I'm gonna try to set it up because she has a little like nightstand. It's actually a huge nightstand by her bed with a bunch of plants on it. And I kind of wanted to put that in the middle and then have waters going all around it. But so far, that's what I have right now. Yeah. It's the size of the box is meant for smaller plants, but the plant does not have to be inside that little container for the soil sensor to reach it. It can be on either side of it, so it can be any size that you want. It's adaptable, like I said. You can just add leads to the end of the soil sensor to stretch it out, so it can be further away, higher up, lower down. Can really work for any plant that you want.
So gardener supplies lining up for.
Might have a little distribution in me, I'm not sure. I have no other questions. I'd like to thank you all again for coming out.
You want Nathan to go?
I'm happy to do it.
You sure?
Yeah.
Oh, okay. All right.